In this video, we'll be looking at our linear regression notes, part 2. We will be talking about how to use technology to find the least squared regression line. If you haven't viewed the part 1, you should. Reviewing our notes from part 1. We saw that the least squared regression line was defined by this equation. Y hat is equal to a plus bx, where a is the y-intercept and is given by y bar, the mean y, minus b times x bar, and this value b is the slope, which is equal to r, the correlation coefficient, times the standard deviation of y times the standard deviation of x. I'm going to copy this section so we can look at it a little closer. Alright, so once again, y hat, this is our prediction equation, is a plus bx, where a is the y-intercept, the mean y minus the slope times the mean x, and the slope is the correlation coefficient times the standard deviation of y divided by the standard deviation of x. We're now going to go to Excel. Reference page 172 from the digital pictures of the book. This is the problem that we discussed in our last class. This problem dealt with numbers of acres burned in timber sales. At this time, pause the video and enter in those values. This is from page 172, problem number 4.4. Enter these values in at this time. Okay. Now that you have the values in, we're going to have to calculate a few things. We have to find this a and b value. A being the mean y, that's what y bar is, minus b times x bar, and b, the slope, being the correlation coefficient times the standard deviation of x, standard deviation of y. There's 5 quantities we need, and I've labeled them here. Mean x, mean y, standard deviation of x, standard deviation y, correlation r. Alright, beginning with mean x. I simply click on this box and hit equals. Mean is the average. Just type in AVE and you'll see you get average. Not that top one, average deviation. You simply want average. Click on that and highlight the numbers you want averaged. We want the x values there. Alright, 278.18. That's the average of these numbers. Now I want the average of my y values. Again, AVE. See average there. Highlighting these values. Hit enter. We've just calculated these averages. Now I want the standard deviation of x and y. Well, remember, standard deviation is a measure of spread. It's a typical distance from the mean. So, again, equals. Now I type ST. And you'll see standard deviation. There's 2, P and S. P is the population. S is the standard deviation. S is the sample. We want the sample standard deviation. Click on that one. Simply highlight my x values again. Hit enter. 121. That's my standard deviation of my x values. Again, standard deviation of the y. Enter. ST. Standard deviation. Sample. Clicking on the y values. Hit enter. Lastly, correlation. We calculated this last time. It was like 0.33, but again, we do equals CORR. We get correlation. It says array 1 and array 2. We first highlight the x's. All of the x's. First highlight the x's. Comma. Then we'll highlight the y's. I had one cell too many here. You see it went through B13. I wanted it to be 12. Now I've highlighted the y's. And there it is. Now I'm ready to go. A, the y-intercept, is given to us by y bar minus b times x bar. So, since A contains b, we need to find the b value first. B, the slope, is the correlation coefficient times the standard deviation of y over the standard deviation of x. This makes sense if you recall the definition of slope. Slope is a change in y divided by the change in x. And here you see we have that. standard deviation of y over the standard deviation of x. So you hear we have this y divided by x quantity. All right, so I will say equals, I want r. Well, r is in this cell right here. Simply click on that. Times, Shift 8 for times. And now I'm going to go open parentheses, standard deviation of y divided by standard deviation of x. There's my standard deviation of y divided by standard deviation of x. And you see this number is very, very low, 0.009. That's about 0.01. This makes sense because if you notice our standard deviation of x, the denominator here is much larger than the standard deviation of y. Little divided by big is little. That's why this number is so small. Alright, now the y-intercept. This is going to equal y bar, that's our mean y, that's this number. Subtract. B, we just calculated. It's this number right here. Click on that. Times x bar, that's our mean x. And our mean x is this cell here. Alright, so there we have it. Now we're ready simply to fill in the blanks. Our lsrl, our least square regression line, is y equals a plus bx. So I'm simply just writing this in. Y is a is 4.905. I'm going to call that 4.91. Plus bx, well, b is this 0.0096. I'm going to call that 0.01, rounded to the hundredths, x. This is our least squared regression line. Y equals 4.91 plus 0.01x, where x represents the acres burned and y represents the predicted timber sales. I'm going to graph this data and we'll take a look at it. So to graph it, we simply highlight the data, including our labels. You can right click and select quick analysis. If you don't have this, you can go to insert and then find where it calls for a particular type chart, I mean to say. After quick analysis, select charts. And then underneath charts, select scatter. And here's our scatter plot. We can see it spread out, significant spread. It's pretty clear why we have a correlation, why our correlation is 0.335. It's a weak positive trend. We can see that it is moving upwards from left to right, but the spread is great about some trend line. Okay. Now I'm going to title this Timber Sales versus Acres Burned. When you title a chart, it should be Y versus X. Now I'm going to insert a trend line. Here's the way we do that. To insert your trend line, click on your graph and you will see these icons on the right. Simply click this little add symbol. You'll see near the bottom it says trend line. If you select the arrow, you'll see several versions. We want the linear, the least squared regression line. And here you see it gives the line. One thing of note, it doesn't draw a line like our lines in algebra with arrows on the end that extend forever. It ends where our first data point, it begins where the first data point is and it ends where the last data point is. This refers back to our concept of extrapolation. We shouldn't use our least squared regression model for values outside of our domain. We shouldn't use it below this value here, which is 80, and we shouldn't use it above this value here, which is 450. You can see that this trend line is exactly this equation. Notice the y-intercept is 4.91. If you extended this line down, it would strike at roughly 5. Notice our slope is 0.01. Said another way, if we multiply this by 100, for every 100 we move to the right, it's moving up 1. And you'll see that here. If we move 100 to the right, it moves up 1. 100 to the right, it moves up 1. Slope is, this is how much the y value changes per unit x. So for every 1 change in x, it changes 0.01 in y. Stated another way, for every 100 in X, it changes 1 in Y. Alright, that's how you use Excel to calculate your trend line. I'm now going to show a website that will be helpful with that. Alright, so go to Google and search lsrl calculator. And the second hit that you get is least squared regression line calculator. You can click on this, tell it the number of data points that you want to enter. For our case, it's 11. All right. Then once you type 11, it has all this information in here. Simply put your values in, and I've already done this, and I can show you the output. Here's our 11 values. All right, I hit calculate, and it returned the slope and the y-intercept, and you can see that's the same as we had before. 0.01 was our slope, and 4.906 is our y-intercept. That is how you can do this using a website. All right, one last method. I'll show you how you can do it using your TI calculator. All you have to do is, after turning your calculator on, come to Stat and Edit. In List 1, you put your X values. In List 2, you enter your Y values. After entering your X values in List 1 and your Y values in List 2, you will come back to Stat. You will come over to Calculate, and then you can select 4 for linear regression, or the one we typically use in statistics is 8, and it gives it to us in this form, A plus BX. It will tell you your least squared regression line, and that's how you perform a linear regression with a TI-84 or similar calculator. And that concludes this video.